Thank you, Ilaria.
Thank you. Sorry for being here twice in the morning. Sorry. Unfortunately, when I loaded the presentation, the font changed, so now we have a really missed, I don't know. Anyway, thanks a lot. So we will talk about big data, and the big data we manipulated, we organized, come from Conservitalia. Conservitalia is a consortium that stores and markets some vegetable products and produces mainly canned food and fruit and vegetable juice. Conservitalia is accredited to analyze or to perform a multi-residual analysis on these vegetable products. So if we consider the definition of big data, at least we can confirm the veracity of our data. So the data set we handled cover a time lapse of 10 years from 2007 to 2016. The number of samples are about a little bit lower than 600 units. The number of data processed are 2,002,000 and more data. The origin of the samples is Italian. So what we looked was the multi-residual content, of course I'm talking about pesticide, in plants, especially for vegetables, so green bean, chickpea, pinto bean, corn with husk, and pea, and tomato, and fruit has apple, pear, apricot, peach, and plum. The origin of these samples are mainly at 75% from the north of Italy and a small percentage from the center, 8%, and 17% from the south. What we decided to do, okay, the part missing is data. Then you have always the imagine is not centered. Anyway, so we divided we decided to present the data as a class of agrochemicals, insecticide, fungicide, and herbicide. We elaborated the data year by year. Especially for the average concentration contained in each crop and the number of agrochemical detected per sample. Of course, we checked the geographical origin in Italy. And we produced the figure representing agrochemicals most frequently detected. For people who are familiar with the report of EFSA, we follow the same type of presentation. Not because our samples are food, because we are at the pre-harvest step, but just because we believe that is a good organization to think about the results. So let's see the big data. Here we are looking at the grouped data. So as I told you, we have a geographical distribution which is not homogeneous. In fact, we have more than 4,000 samples coming from the north of Italy, just a few samples, 400 from the center, and about 1,000 from the south. If we look at the average concentration, we are here, at the average concentration of insecticide and fungicide, because herbicide were almost absent in the north center, in samples coming from north, center, and south, we can see already a different distribution of this average concentration. In this picture, we can observe the number of active ingredient detected per sample in the grouped data from the north, center, and south. We can observe that the center, for example, has the highest number of sample containing the highest number of sample containing with active ingredients below the limit of quantification. Sorry, it's a little bit tricky. So, if we look at the distribution of the big data year by year, we can observe, and this was expected, a reduction of the use of insecticide as ppm, this is the unit, and an increase of fungicide, at least from 2010 or 2008. Also, this was expected because we are observing resistance to fungicide, so we just confirmed what we know from the phytosanitary service, Italian phytosanitary service. So, the frequency of samples were 0, 1, 2, 3, 4, or more than 4 active ingredients detected has a, let's say, not constant trend, but we can observe that at the end of this time lapse, the frequency of samples containing 4 and more active ingredient is a little bit higher. This is the composition of our big data, so 1/4 made of fruit samples and the remaining part, the biggest part, of vegetables. So, talking about vegetables, the number of samples considered were 4,000, and 50 of them were composed by tomato samples. So we have a big figure related to tomato production. Then we have pinto bean and pea plants. So here I want just to show you very quickly the elaboration on tomato, because tomato is an Italian product. This is an international conference, so we want to talk about tomato. So if we look at the distribution of, if we look at the average concentration among north, center, and south for tomato, we can observe that this value is clearly higher in the south for fungicide and insecticide for both. Here we can see that accordingly the number of samples containing, the frequency of detection in samples containing 4 or more active ingredients in the south of Italy is higher. Of course, this is connected to the weather, to the precipitation. There are meteorological data connected to this result. And as I told you before, we also produced the frequency of detection of active ingredient. We can observe that the most detective molecules are insecticide. Blue is insecticide and red is fungicide. This is just to quickly read this graph. So we produced this frequency of detection for tomato. Okay, so just a very quick look to pea plant, because it is the second biggest component of the vegetable big data. Even in this case, we observe a decreasing in insecticide and increasing in fungicide, and the average concentration, of course, and also we can observe a higher percentage of samples containing more than 1, 2, 3, 4, or higher than 4 active ingredient in the evaluated sample. These samples come from the north of Italy, and this is the average concentration of the grouped data for insecticide and fungicide, and here the frequency of detection of the number of active ingredients. We have also the frequency of detection for the active ingredients for the grouped data. Now, if we look at the vegetable sample, we can observe a trend which is a little bit different from the big data in total, but still we can observe a decrease in insecticide and a small increase of fungicide, at least from 2010. The number of active ingredients revealed in the sample are increasing. And this is quite, it was expected because commercial products usually contain more than one active ingredient, this to fight the resistance. The vegetables are from the north. This is the content, the average concentration of the vegetable. Here we have a different situation from tomato. In fact, we have a highest average concentration of insecticide and fungicide in the north of Italy. Okay, and here we have the number of active ingredients. Now, this is the frequency of detection of our active ingredients. I don't want to spend more words on this. Fruit. The number of samples was lower, 1,400, and the data was composed mainly, at least 53%, by peer sample. So for this reason, I want just to show you very quickly the results on peer. Even in this case, we observe a decrease in the insecticide average concentration in the time lapse of 10 years and an increase of the fungicide, which is decreasing. So we have a two curves, okay, for insecticide and fungicide. We are observing an increasing in the number of active ingredients in the last years. Peer comes from the north of Italy, and this is the frequency of detection of the number of active ingredients in this fruit sample. This is for the fruit in general. We confirm what we observed for the vegetables, an increasing in the fungicide and a decreasing in the insecticide with a higher frequency of number of active ingredients detected per sample. Well, in this case, we have the most frequently detected active ingredient, which is a fungicide. And then we have the distribution among the other class of agrochemicals. So just to start with the, not conclusion, but some consideration, we can say that, of course, we can create an order of the average concentration observed for pesticide observed in these crops at pre-harvest. Green bean plants were the most let's say polluted because we are in the environment, followed by pinto bean plant, pea, chicken pea, corn, and tomato. This is related to the fact that we consume legumes without pods. So for green bean we can observe a problem. In fact, among food is one of the most contaminated vegetable. But for the other, the problem is under control because you eliminate the pods before eating, of course, legumes. Well, in this graph, we tried to correlate the sales of in this graph, we are looking at the percentage of samples below the limit of quantification. So it's not zero residue, but you cannot measure any residue, or you cannot give any number, okay? So at pre-harvest, of course, we have a percentage which is lower than those reported by the Italian Ministry of Health for the food, and this is, of course, what it was expected. This is for fruit, and this is for vegetables, okay? Because at pre-harvest, of course, you need to wait more day before you can consume the food, and so this percentage is lower. Then we try to correlate the average concentration for the big data, the group data distributed in 10 years of observation with the sales of active ingredient. These data are taken from ISTAT, the Italian Statistical Institute, producing this data. So we are correlating sales, so thousands of tons sold in Italy, with the average concentration found on the crops at pre-harvest. And it was quite interesting to observe that for insecticide, there was quite a good correlation between the Italian sales and the average concentration at pre-harvest on crops, while for fungicide the correlation was not good. But if we consider that fungicide are mainly used on fruit which comes from the north of Italy, if we made the same correlation considering the sales in the north of Italy, we can see that the correlation is much better. So this means that what we are observing is an environmental data because it's connected to sales, okay, and not to the food quality, of course. Then, if we group the big data and we consider the active ingredient most frequently detected. And if here we decided to present the initial and the final part of this study, if we consider for vegetables the year 2007 with the 2016, we can observe that the frequency of detection is much lower in 2016 than 2007, and the number of active ingredients detected are much higher. This, of course, is connected to the fact that we are using a higher number of molecules for defense, for crop defense, and also we are looking at a higher number of molecules. Of course, I'm talking about the green part of this graph. There are some small bar in blue. Sorry, the difference of color is not so straightforward, but this is the value reported by EFSA for food, for Italian food. And this is just to show that the molecules detected from this study at pre-harvest are completely different from what is reported for food. So we are observing really different subject, even if the plant or the fruit will become food very soon, okay? Okay. Then this is for fruit, and we have more or less the same situation. So we have less molecules detected in 2007 and a lot of molecules detected in 2016. Of course, Conserve Italia is a laboratory which monitors a higher number, always monitored a highest number, with a higher number of molecules with respect to the national monitoring. So, just to conclude, I finished all the available time. The elaborated data for sure has a valuable, can be used to consider the elaborated data on single crop at pre-harvest can give information on use and misuse of pesticide, for example, admitted and not admitted, because sometimes you treat a plant and you are sure that the legume you are going to eat in a few days later do not contain the molecule because it remains on the pods. It was interesting to observe a correlation between the trend of active ingredient average concentration in 10 years to the trend with the sale for the same period. And this is the connection important for the environmental point of view. And as I just said, in 10-year time lapse, a higher number of active ingredient at lower concentration detected on crops at pre-harvest. This is due, of course, or likely to the lower half-time of these molecules, but likely even because of best practice is followed by the farmers. So for sure the next step is to evaluate the possible correlation of the half-life time of active ingredients with our data, but also the meteorological data, so the average temperature and, of course, precipitation. So we are continuing to elaborating this data, and we arrived at this point. Thanks a lot.